when the charges are moving through a circuit, they don't have electrical energy. Once they return, their electrical energy is zero. They have kinetic energy. The movement is there. Why? Because of the repulsion, they are continuously moving through a circuit. Because what happened? Look, if this is a battery, if this is a those who studied electrolysis can understand the concept of the battery easily. Example, if this is the battery which contain electrodes and electrolyte. So these are the two electrodes. One is made up of more reactive than the other. So more reactive metal go inside the solution and it will turn into positive ion and it will transfer its electrons. So it will have more electrons on its surface. And electrons are like charges. So like charges, what they will do? The like charges will repel each other. So as these like charges will repel each other, they start to move. Example, if I say I use two metals, difference in their reactivity, and this is responsible for producing 2 volts. So they can produce 2 volts. So what's the meaning that they can produce 2 volts? It means when one charge is there, 1 coulomb of a charge, how much energy this charge can carry? This charge can carry 2 joules of energy. And when this charge reaches this point, and because these are like charges are repelling, so as they are repelling each other, they all start to move. So as they all start to move, what happened? Due to repulsion, they are moving, but each of them carry 2 joules of energy. But as they carry 2 joules of energy, before entering the lamp, it's 2 joule. But moment they enter and pass through the lamp, they transfer their energy. So they have 0 joule of energy to transfer. But why still, if they don't have, if they have 0 joule, how they are able to move? Because they don't have energy to transfer, but there is a repulsion because continuously the charges are moving. So they are repelling each other. So they force each other to return back to the battery. So the movement will be there. The movement of the charge is called current, and energy transfer by the charge is known as voltage. So in electrical circuit, the working of the circuit depends on both things. It depends on the current because it should be a continuous flow and the charges should have enough energy to transfer so that the device can work. Is it clear the concept here? The flow of the charges is called current and the transfer of energy by the charge is known as potential difference or voltage. So if there's a lamp, like 3 lamps are there, so example, you have 3 lamps, they are connected in series and you have a 6-volt supply. So what happened? There's a chemical reaction, so it produces charges. So these are the charges which are moving. The flow of the
6
charge,
joules in every.
6 joule is carried by every charge. Each charge is carrying 6 joules of.
But sir, every
Energy.
lamp will get equal charge.
Yeah, because each they're in series. So if they are in series, they will have the same current. And if I say it is 2 ampere, what is the meaning of 2 ampere? It means two charges are flowing in 1 second. 2 coulomb per second, it means 2 ampere. Ampere is a unit of current. It shows the flow of the charges. So when the charges are moving through a circuit, because
But
they are
sir,
in
what
series,
about
what about?
potential difference?
Yeah, I'm coming to that point. So what is the meaning of 6 volt? 6 volt means EMF is 6, means every charge will carry 6 joules, or each charge is carrying 6 joules of energy. So if I take this as a charge, so how much energy it will carry? This will carry 6 joules. How much energy the second charge carry? It will also carry 6. How much energy the third charge carry? 6. All of them carry the same amount of energy because EMF is 6. So what that's the energy which the charges take from the supply or a battery. Before entering example, if it is 6 joules, every charge were having 6 joule. When it passes through, it's having 4 joules. So what is the potential difference? Means how much energy is converted into other form.
Two,
2 joules
two.
is converted by every charge. So what will be the voltage here? The potential difference will be 2 volts. If this is 4 joules and after passing through, it's having example 2 joules. So what is the potential difference across L2?
Four.
It is 4 joules. When it passes through, it has 2 joules, the charge. So how much energy
Yeah, it's two.
transfer?
It's two now.
So how much energy transfer by the charge? That's equal to, and it is 2 joules. When it passes, it transfer all of its energy. It's having 0 joule to transfer. So how much energy is there carried by this
Two.
charge? The potential difference is 2, and energy, now there is no electrical energy to transfer. So if there is no electrical energy to transfer, then what does it mean? It means the charge should stop here, but it will not stop. Why it will not stop? Because the other charges are
Attraction.
also repelling, like charges repel. So other charges are also pushing these charges so that they flow out and move towards the
Yeah.
terminal. So, and this movement or the flow of the charges is known as electrical current. So there is a current which is a movement of the charges, and the charges, when they move, they transfer the energy. The energy which the charges transfer we call potential difference, and the energy which the charges get from the supply or the battery is known as electromotive force or EMF. Is it clear the concept of EMF and potential difference? Then voltage in the circuits. A circuit can be a series circuit. It can be a parallel circuit. Series circuit means charges have only one way to flow. Parallel means they have multiple ways to flow through the components. So example, you have two lamps, one next to the other, and here two lamps, one down of the other. When they have multiple ways, and here they have only one way to flow. So now we are discussing what will happen to voltage in a circuit if the circuit it's series or if it is parallel. So example, if I say it is labeled 2V, okay. So if there is one charge, how much energy it carry? 2 joules. Every coulomb of a charge carry 2 joule. Each coulomb 2 joules. Before entering it is 2 joules. But when it passes, it's having example 1 joule. So what is the potential difference here? What is the voltage here at across L1? So that's equal to 1. When it passes through the second one, it will have 0 joules to transfer. So that's also 1. So what happened, you can see here in series circuits, voltage divide between the components. So if there is a series circuit, what will happen? The voltage will divide between the components. But if it's a parallel circuit, example, if one charge is coming and it's also a 2-volt supply, how much energy this charge will carry? It's carry 2 joules per coulomb. But what happened? Example, when this charge reach here, it has only one possibility to flow. Either this charge can flow up or it can, 1 coulomb of a charge, either it can go up or it can go down. So example, if this 1 coulomb of a charge flow up, so before entering it is 2, and after passing through the component, it will transfer all of its energy. Why this charge will transfer all of its energy? Because you can see here, there is no other component in the passage. So if there is no other component in the passage, so it will transfer all of its energy to that component, one component. So what is the voltage here or potential difference? The potential difference is 2 volts. And if there is another charge, example, the blue one is blue line, blue shade is representing another charge that will also carry 2 joules. So when it start to flow, if the example, the red charge move, it can go down as well. I just took, if it can go either up or down. Only one passage it can flow. So first
Sir,
one,
but it
yes, it's a 1
it
coulomb
will
of,
take 2 joules.
so every charge,
Like,
each charge carry 2 joules. So example, if the first charge which enter, now this position, when the charge is at this position, either it can take path 1 or it can take path 2. So what happened, how it will flow? Because the direction or the conventional current is always from positive terminal to negative. So if the charges enter from positive terminal, it should go to negative terminal. It cannot just make a loop. Like if you're saying that the charge should move in this manner. So if it go in this manner, it means it has to return to the same terminal. So it cannot return to the same terminal. It will return to opposite terminal. So it enter from positive. So if it take passage 1, then it cannot go down to the second lamp, because if it go down to the second lamp, it means it has to return to the same positive terminal. So what happened? The charge moved from positive terminal to negative terminal. Yes, Salman?
Sir, I have one question.
Yes.
Can it go like this, for example? Like, can I draw?
Yes, sure.
Like from here, like one goes down here and one goes up here. Can it be like that? And then they both join from here.
This is a one charge, 1 coulomb of a charge. So what happened, like this is normally what happened, that if you have one charge or 1 coulomb of a charge which carry 2 joules, So if 1 coulomb of a charge flow up, the other coulomb will flow through down. Other charge will flow down. And how much energy they transfer? Because before entering the second charge, if I say two charges were there, one I'm representing with a black spot, another one example with a blue. So if there's another charge, because the like charges are repelling each other, these are identical charges. So when the second charge is moving, so how it will move, it will take definitely the second path. Why it is taking a second path? Because the like charges are repelling each other. So when they're far apart from each other, they will have minimum repulsion. So this point, the repulsion will be minimum. So they spread. Like if one charge flow through the first passage, the second charge will flow through the second passage. But how much energy each charge is having? Each charge is having 2 joules of energy. Now, when they pass through the component, because if you take this charge, the blue charge, there's no other component in the passage. If you take the black charge, there's no other component in the passage. So both of the charges, this is the only component which they have to pass. So what we observe the charges transfer almost all of their energy to this component. So when they transfer all of its energy, how much is the voltage here or potential difference? 2 volts. And how much is the voltage here? Potential difference will be 2 volts. So the idea is that whenever two components are in parallel, the voltage across the component is same. So they transfer same amount of energy when they passes through. So both lamp will, because it happened in a short time. So both lamp will light up at it appeared both lamp light up at the same time. One coulomb of a charge which carry 2 joule, it cannot further divide. So that's why it does not break down. So whenever you have two components in parallel, the voltage or energy transfer by every coulomb of a charge is same. So in parallel, the voltage is same. In series, the current is same. And in series, the voltage
Sir,
divide. Yes.
sir, in parallel circuits, why don't the charges repel
Why?
when going out of the branch?
They are repelling each other. That's why due to this repulsion, they force each other to go out from the circuit. The charges are repelling, like the charges when they're moving, because if one of the charge is a bit ahead of the other one, as you can see, as the charges are moving, if this first charge take this position, then the second charge will be a bit lag behind the first one. So when the first charge enter and the second charge move, they force each other to return to the battery.
What if they are equal and they face each
It
other?
practically it cannot be equal. Reason for that, because it's obvious, like if you have one passage, so if charge one enter, then the second one will be charged to always lag behind charge one.
Yeah, all right.
So basic, but it's a very small difference that it does not appear that maybe in a nano of a second, or a it maybe this lamp will light up a nanosecond earlier than the second one. But nanosecond you cannot detect with your eye that the time interval, like that the interval at which it is appear that the both lamp light up at the same time. So in parallel the voltage divide, sorry, in parallel the voltage is same, whereas in series the voltage divide between the component or energy when the charges are moving. If one charge, because it's like charge cannot be half here, if one charge is there, if this charge move up, the other charge which is following should move down. Is it clear, the concept of voltage in the circuits? So voltage is in parallel. That's why when we connect a voltmeter,
So parallel circuits have more energy.
the parallel circuits are useful because using a same supply, I can light up more lamps. Like example, if I have 3 lamps, okay, and I connect all of them in parallel, parallel circuits have more advantage than series circuits. So if this is 3 volts, how much voltage across lamp 1, lamp 2, and lamp 3? If they are all parallel, if the voltage of the supply is 3, what is the voltage here? Because they are in
3.
parallel, so this will be 3. What is the voltage here? 3. And what is the voltage here? Also 3. So whenever components are connected in parallel, they will receive or they will have the same voltage. But if the same lamps, I connect them in series, the same 3 lamps, now I connect them in series with each other. With the same supply of 3 volts. So what happen if I connect to a same supply? What is the potential difference here? 1. This will be 1 and this will also be 1. So which one you think is advantage? Series circuits or parallel circuits? Like which circuits are useful? So parallel circuits are useful, and these parallel circuits, there's another advantage also, that if one of in series circuit, if one component is faulty, the whole circuit will stop working. Like example, if this lamp is not working properly, like if this lamp filament is broken, so what happened? The whole circuit will break because the charges that does not have a part to flow. If the charges does not have complete part to flow, the charges even will not come out from the battery and they will remain inside the battery. So the disadvantage of series circuit, if one component is faulty, all the other components will stop working. But what is the advantage here for a parallel circuit? For example, if this lamp is not working properly, if this lamp is faulty, the circuit will continue to work. Why it will continue to work? Because the charges have other paths to flow, so they can flow through the other path and the other components will still work. So parallel circuits have more advantages, like having greater significance as compared to series circuits. So whenever we want to connect a voltmeter, we always connect a voltmeter in parallel, because in parallel voltage is same. So if there's a circuit which is having example lamp and a battery, so this is a positive and negative terminal. So what happened? So example, the current will start to flow. If I say I want to measure a voltage of the battery, so how I should connect a voltmeter? I should connect voltmeter in parallel to battery. If I want to measure the voltage of lamp 1, so I should connect voltmeter parallel to lamp 1. If I want to measure voltage of lamp 2, so I should connect voltmeter parallel to lamp 2. So voltmeters are always connected in parallel to a component, because in parallel the voltage is same. Example, if this is 2 volts, how much voltmeter will record? What will the voltage record by the voltmeter? That will also be equal to 2. And if this is 3 volts, how much voltage recorded by the voltmeter? It will also record 3V. Now, what is the voltage from the supply? What will be this value? So voltage of the supply is equals to 5 volts. So in series, whenever we connect a voltmeter, we always connect voltmeter in parallel to a component which we were finding the voltage. And same way, if you have components which are connected in parallel, example, 2 lamps are there. So in this case, as we know that 2 lamps, the voltage of lamp 1 will be same as voltage of lamp 2. So we don't have to connect 2 voltmeter. 1 voltmeter either across lamp 1 or lamp 2 is sufficient. I can connect a voltmeter here. That will give me voltage of lamp 1, and that is same as voltage of lamp 2. And that is same as voltage of the battery. So if this voltmeter record 3 volts, how much voltage recorded by the lamp 1 voltmeter? That will also record 3 volts. The voltmeter is actually in parallel. I place it in parallel. So it should be parallel to a component, because the voltage of a supply will be same as voltage recorded by the voltmeter when it is in parallel. So electromotive force is how much energy the charges carry due to electrochemical reaction. And if you connect the cells in series, like example, when cells are connected in series, what is the combined EMF is equals to sum of individual. So here, what is the total voltage? What will the total EMF? 1.5, 1.5, 1.5. What's the total EMF here? So that will be equal to 4.5. And when cells are connected in parallel, but if I change the terminal here, for example, if one of the terminal I changed, So this one is negative and the other one is positive. Now, what is the voltage produced? Combined voltage. What is the combined voltage produced here? So the combined voltage produced here will be equal to 1.5. Why it will be 1.5? Because these two cells are try to transfer energy in opposite direction. So these two cells will cancel out each other. So when these two cells cancel out, the total voltage is because of one cell. It's not 2.5, it's 3 minus 1.5. Because these two are in the same direction. These two are in the same direction, so make 3. This is opposite direction, so minus 1.5. So 3 minus 1.5, you will get same as 1.5. But when cells are connected, and what is the use of this combination? You will find, like example, if you are buying a like a remote control is there or a remote control car is there. So when you place the cell, so how you place the cell? Actually, these cells are in series. How they're in series with each other? This is the positive terminal. Like example, in a car, you place 4 dry cells, one next to the other. So basically what happened, this is a series combination. How it's a series combination? Because it's connected in this manner. And what is the advantage here when we connect these cells in series? This is positive, negative, positive, negative, positive, negative, positive, negative. So if each cell is 1.5, what is the total voltage produced by? What will be the total voltage produced here if each cell is 1.5?
6.
So that will be equal to 6 volts. So that's how you, like even in a remote control, you're placing two cells, one next to other, but how they're connected internally. So if one cell you place, then the other cell you place in opposite direction. Why you place in opposite direction? Because what it will do, how they're connected, there's a metal strip is there. Maybe you have seen this metal strip when you check the remote. So this metal strip is actually connect the two cells positive with negative. So negative, positive, and negative, positive, and then it supply. So the total voltage will be, if each is 1.5, the total voltage will be 3 volts. And that's why if one of the cell, like example, what happened if one of the cell is not working properly, the combined voltage will decrease. And when cells are connected in parallel, the combined EMF is equals to EMF of the individual. So 1.5, 1.5, 1.5. So that's equal to 1.5 only. Now, what is the answer for this one? What is the combined voltage produced by this combination? What's a combined? So this will produce. What's the total combined produce? Because this part is in series, all are in series, so it will produce 6. This will produce 6.
So 18 total.
This will also produce 6, and this will also produce 6. So, but they all are in parallel, and in parallel the voltage is same. So what is the combined voltage? The combined voltage is actually 6 volts here.
So, but sir, but the total is 18.
No, you don't. The thing is, you're adding, because in parallel the voltage is same. So what happened? 2 plus 2 plus 2,
Yeah.
that's 6 volt.
Yes.
And this is also 6, but all are in parallel. If all are in parallel, the voltage is same. It means the total voltage, what they will provide 6 volt. But what is the advantage of connecting the devices, the lamps in or these cells in parallel? Means this combination will last for a longer period of a time. Like if I have, this is giving me 6 volt. Okay, this combination 2 2 and 2. So this is combination is giving me 6 volt. But when I connect this, I use this combination, this is also giving me 6 volt. But what is the advantage of using this combination rather than the series one? This will last for a longer period of a time. You can see more batteries are there, so it means more charges. So this combination provide the same 6 volt, but it will last for a longer period of a time, or the device will work for greater time period. Is it clear? The difference between the current and the voltage. So we started with the concept of, I will just quickly recall what we took. You should be able to remember these things. This is a base of electricity. Like if you understand this concept about current and voltage, then other parts of electricity are applications only. So it's very important to understand this concept, basic concept. Electric current is the flow of the charges. When the charges move, we call electric current. It can be conventional, it can be electron flow, and current can be from AC supply, it can be from DC supply. AC supply, the current changes continuously, but DC supply, the current remain unchanged. And we use an ammeter to measure the current in the circuit. And ammeters are always connected in series because in series the current is same. This we did some examples. Then electromotive force or EMF, it's how much energy the charge get. That's called electromotive force. And how much energy the charges transfer, that is called potential difference. And when we want to connect a voltmeter, this is a symbol for the voltmeter. Voltmeter are always connected in parallel. So we discuss current and voltage, which are the important topics. Any question related to the class today? I'll end the session otherwise. Ammeter is always in series because series the current is same. Voltmeter always in parallel because in parallel the voltage is same. So example, if you connect a 220 volt supply to 110, so it will not work efficiently.